Welcome, humans. You are listening to the AI Wars podcast.
All right, welcome to the AI Wars podcast. We are here to discuss Scott Aaronson's recent progress in AI, specifically whether or not we can watermark large language models, and some of your other thoughts about language models, the progress of AI. Super grateful that you're giving us your time, so thanks for that.
Well, thanks for having me.
Yeah. For those that don't know, Scott is a polymath of sorts. He's a professor of computer science here at the University of Texas. He's won multiple awards, been a professor here for 10?
This is my 8th year.
8th year. Before that, you were at MIT?
I was.
Yeah, amazing. So thanks again. So I guess, to open it up.
Sure.
Is it possible to watermark an LLM?
Well, it is certainly possible. If you're not worried about all the sort of crazy attacks that people will execute to get around your watermarking. If you are worried about it, then and you want to know who will ultimately win, sort of the watermarkers or the people trying to evade watermarking, then I would say that is an open research question.
So one case in which this becomes relevant is sort of when you're asking LLM for some sort of quantitative answer that does not really change. Right, So if I'm cheating on my physics homework and I give it a problem and it just spits out an answer and there's not much text there, how does that be?
Yeah. So we should back up a little because so what does watermarking mean? Right. It means inserting some sort of statistical signal into the choice of tokens, like words, punctuation marks, numerals, and so forth, that are generated by a large language model that will help you prove later that, yes, this output really came from this model, right? And that could be useful for addressing, almost any misuse that you could imagine of large language models, right? Almost all of which, if you think about it, involve in one way or another concealing the fact that a large language model was involved, right? Whether that means academic cheating, which is, surely the most rampant misuse of language models right now, even if not ultimately the most important one.
They're out there right now cheating.
Indeed.
Maybe in this building.
Indeed. I'm sure. No, I mean, we've now seen a semester where a significant portion of all homework was probably done, licitly or illicitly with ChatGPT assistance. We saw the total usage of ChatGPT noticeably decline at the beginning of the summer. Right. If it goes back up, this month, then we'll know for sure what was behind that.
Wait, okay, so does that mean that your students, have you caught any of them using GPT?
I have not caught any of my students using GPT. Although I've also been on leave to work at OpenAI, so I haven't been teaching undergraduate classes. So, but I have gotten numerous troll comments on submitted to my blog that I'm almost certain are LLM generated.
Wow.
And that's without using a watermark, just because they're written in that telltale formulaic way.
That's maybe a sign. Maybe the LLMs are afraid of you. Watermarking them, and they're trying to troll you. They're trying to stop you.
Well, but if so, then they're achieving the very opposite of their objective, because that just every troll just hardens me to want to solve this problem more. Well, it makes me more motivated to solve the problem, so yeah. But I mean, you can also think about trolls, which might just be random loners, but it could be, let's say, a Russian government agency spamming every comment section with pro-Putin talking points, right? It could be someone impersonating someone else for financial gain or for other reasons. It could be spam, political disinformation campaigns, right? So basically, if GPT, is being used for any of that stuff, then, you would like to be able to unmask the use.
Sure.
Right? And so there were several different approaches that you could imagine to that task. One of them is you just eyeball the text, right, and try to see, does this look like an LLM wrote it? And in fact, a significant number of homework assignments have now been turned in that contain text like as a large language model trained by OpenAI, so sometimes it's really obvious, but you have to assume that people will get a little more sophisticated than that.
I believe you can find this on Google Scholar if you search that as an AI language model. I think there are many papers already.
That's right. Or you just look for the references to papers that don't exist, right? Which at least until that problem of hallucinated references gets fixed. Another thing that you could do is you could treat this as just yet another AI problem. So you can train a discriminator model to just distinguish human from LLM generated text as well as it can. Now this was actually done over the last year. There was an undergrad at Princeton named Edward Tian who set up a service called GPT-0. It then I think his server crashed within a day from like the sheer volume of professors and teachers wanting to use this. OpenAI had its own discriminator model that was up for maybe half a year called Detect GPT, but that was since taken offline. And a big problem with these models is that they might have a 10% or 20% error rate, right? But that includes false positives.
Right. I was gonna ask, how is it?
Yes.
Yeah. How's
Yeah. Exactly. Yeah. No. I mean, both false negatives and false positives might be let's say 10%, depending on what kind of text it is. And even more so than false negatives, right? False positives are a big problem because if you're going to be accusing a student of cheating based on the output of a model, then you want to be right, okay? And we've already seen cases of like professors falsely accusing their students of cheating.
So I have a question
GPT.
actually about false positive rates. And it's based on the idea that humans train on text as well, and if we're training our children, students on LLM generated text, is it possible that then human generated text could converge to LLM generated text and eventually we would watermark ourselves and not even know we're doing it because
watermarks in the brain.
Right. Yeah. I mean I hope that doesn't happen. I mean, the kinds of watermarking schemes that I've been thinking about are produce text that is cryptographically indistinguishable from unwatermarked text. Right, so like if you don't know exactly what to look for, then you should see nothing different from ordinary, right? And so you could read that kind of thing your whole life, and you're not going to be trained to produce it. But to your broader question, I mean, it's possible that the way that humans write is going to evolve, right?
Sure.
It's by the way, related to what you asked, is yet another application of watermarking or some solution to this attribution problem, which is the internet is going to get more and more filled up with LLM generated text. Right, and if we can't identify which text is LLM generated, that's going to get fed back in to train the next round of LLMs, right? And so the LLMs are going to be fed on their own outputs, and that might make them, get further and further from the human behavior that we're trying to get them to emulate, right? And so there's a lot of reasons to care about this attribution problem. Now, some people might say, well, if everything is being run on, let's say, OpenAI servers or Anthropic servers or whatever, then why don't we just cache all of the outputs that we generate? Just store them in some giant database somewhere, and then let people make queries where they can ask, is this in the database? Is there anything in the database that's a close match for this text? Right? Now, you could do that. As soon as you try to do it, you open a gigantic can of worms around privacy. Right?
I think the NSA has a similar program where they store a bunch of data on American computer use, and they just search it when you flag on some sort of database or when they're doing a criminal investigation into you. Then they search their backlog of like 10 years of data.
Is this something that was learned from Snowden?
I believe so. Yeah.
Okay, because where else would we have learned that?
Right. Yeah.
But yeah, I see. So the NSA might have fewer privacy concerns than OpenAI does, for example, right?
Sure,
But,
fair enough.
Which is a public-facing business that has to worry about both the actual privacy and the optics of it, right? If you're exposing the whole previous history of GPT use, right, then if there's any bug, right, then you might have a catastrophic privacy failure. Okay, so then that brings me to the idea of watermarking, right? And with watermarking, you want to slightly change the way that the language model operates, right? Meaning you're not messing with the neural network itself, right? That you're treating as sort of a black box. Okay, but what does a language model ordinarily do, right, in normal operation? Well, again and again, it's being fed a context, which is a sequence of previous tokens, right, which could be the prompt that was entered by the user, or it could also include the language model's own previous output. Okay, and then that gets fed through this particular kind of gigantic neural network called a transformer. And the output is not a specific next word. It's a probability distribution, over all of the possible next tokens. Mm-hmm. Where let's say that, there's about 100,000 possible tokens, and each one gets a probability. Okay, and now if there's this, if you've used GPT, you might have seen there's this parameter temperature, that you can adjust. Right, now if the temperature is 1, then you're telling GPT just sample, token I with probability piece of I being its probability, right? Which is the natural thing to do. If the temperature is 0, then you're telling it always output the token of highest probability, right? So that that's a different way to use these numbers that are output. Okay, but now with watermarking, you want to do neither of those two. What you want is to do something that looks like you are sampling from the distribution that GPT output, right? You want to do something that looks like you're sampling token I with probability piece of I. Okay, but actually you're picking the next token pseudo-randomly, okay? In a way that biases a score that you can calculate later, given the output text, given only the output text. Right, now at detection time, crucially, you're going to have the text, right? But you will not know what prompt might have led to that text being generated,
right?
Which means that you will not know the probabilities, right? So you can't assume that you know the probabilities at detection time. Okay, you have to bias some score, which is a function only of the actual text itself.
So just a question on that. If someone has access to, say, the function that you made,
yes,
how hard would it be to red team it, to make something that you just have this piece of software run over the output and then choose something semantically similar?
No, there are many attacks of that kind, and we'll so we can talk about that. But to address Connor's question, about the questions with a definite right answer, right? So now the key is that there is the key fact about language models that we are exploiting in watermarking is that they are probabilistic, right? It's that they typically there are many choices for the next token that are at least somewhat reasonable, right? There is a garden of forking paths. There are many possible ways of validly answering a question, and so now we can try to steer our own trajectory within that garden of forking paths in a way that encodes a signal that we like. And a key quantitative question is, well, how many tokens do you need in order to pick up the signal, in order to see it reasonably? And the answer to that question will depend on a key parameter, which is the average entropy per token, as perceived by the language model itself. Okay, so for example, let's say that you gave GPT a math problem with a single right answer.
Yeah.
List the first 100 prime numbers, right? Or, calculate, the melting point in Celsius of this substance, or, look up what it is, right? There's basically, no watermarking that you can do there, right? It's, unless you want to play games with the spacing and the line breaks and stuff like that. Okay, right? Because if there's only a single right answer, then that's saying, well, anything that outputs that right answer would be indistinguishable from anything else that did so.
Right.
So what do? Right now, fortunately, we don't really care about those cases, right?
So what I'm hearing is that the STEM majors are safe with cheating on their homework, but not the literature majors.
Well, I mean, STEM majors have long been able to use calculational aids to help them, solve problems that have single right answers. Now, we could talk about how good is GPT at doing those things, and it's my own judgment, having done a lot of experiments around this, is that it's sort of at the level of like a B undergrad in most STEM subjects. That's GPT-4, let's say. GPT 3.5 was maybe more at the level of a high schooler, right? And so that's
also that's not the GPA of the GPT. Then GPT 3.5 was not what it got on the.
Yeah, no, I mean, just looking at the kinds of problems that it is able. I mean, like no matter what problem you give it, it will give you something that looks like an answer, right?
Yeah.
But if the problem is too hard, then that answer may be gibberish. Okay, it and what's so fascinating about GPT, right, is that even when it BS's you, right, the kind of BS it generates is familiar to me from like 1,000 exams that I've graded, right? It's like it'll output something that looks just like a proof, except there's this one step that's complete nonsense and that it's hoping that you won't look at too carefully, right? Okay, but so basically, the more entropy, the more potential there is for watermarking, and so a year ago, I thought about this, and I am not really good at foreseeing the future of AI or looking years or decades ahead, but I'm a little bit proud that I was able to see about 3 months ahead.
That's huge.
But before ChatGPT,
I think it's about 10 years in physics time. Did you say that?
Yeah, I don't know. I mean, before there was ChatGPT and everyone was worried about cheating, I was like, oh my God, this is going to be a huge issue. And not only that, but this is one of the rare problems in AI safety where I might be able to do something useful as a theoretical computer scientist, right? Because I don't have to go inside of the neural net and do all of this messy empirical stuff with it, right? I can just sort of take it as a black box, right? And then just say, like, as a function of the entropy of these distributions over tokens, how many tokens would you need to get a good watermark, right? And that's a pretty clean question. And so, I was able to answer that, right? And basically, like, if the average entropy per token is some number, alpha, let's say it's 0.1 or something, and let's say that you're willing to tolerate a probability of delta of a false positive or a false negative. Maybe delta is 1 in 1,000 or something. Okay, then the number of tokens that you need turns out to scale like 1 over alpha squared times the log of 1 over delta. So that's how it works, and you can try it empirically. We implemented the scheme, and a few hundred tokens tends to be enough to get a decent signal with like normal text. With a few thousand tokens, you have an excellent signal, right? Where like if the detector says that GPT was involved, then 99.9% was involved. Right. So, and you could even go further than that. You could even try to identify which portions of a longer document were written by GPT and which were not.
Yeah.
Okay. So we have algorithms for doing that. And now we come to a really crucial question, which is, well, what is the robustness to perturbations, right? So suppose someone uses GPT to write their term paper, but then they modify it in various ways. Okay. Now the watermarking scheme that I proposed, and I should say that since I came up with it, various academic groups have come up with other watermarking proposals that many of which are very, very similar to mine, many of which improve on mine in different respects. So there's now like since the past year a small literature on this topic, and So the kind of scheme that I came up with uses a pseudo-random function that looks at what are called k-grams, just sequences of k consecutive tokens, right? So like if k is 2, these are called bigrams. If k is 3, they're called trigrams, right? So so you could just use these little sliding units of consecutive words or tokens, and these are the things that we're sort of pseudo-randomly hashing, right? And in order to in this sort of otherwise inscrutable way favor certain word combinations over others, right? And so now because our watermark score is just a sum over all of the k-grams, right? Any modification of the document, if it preserves a large fraction of the k-grams, then you'll still be able to see the signal.
Nice.
Okay, so that means anyone who just added some words, deleted some words, rearranged some sentences or paragraphs, right? You still pick that up. Okay, but now there are other attacks. Okay, so suppose that someone asks GPT, write my term paper but in French, and then they put it into Google Translate.
Oh, interesting.
Right? Well, the watermark is not robust to translating from one language to another one, right? Or, even simpler than that. Suppose they ask for the term paper in Pig Latin.
This is feeling like you're maybe providing an information hazard for your own cover.
Right.
I'm like,
these things are sufficiently obvious that there's no hope of
sufficiently obvious to a quantum computing professor.
Well, I guess, but no, and the stuff has already been in the literature anyway, right? So but it's also I feel like 40 years ago, right? Like people could have said, well, it's really, really easy to pirate software, right? And no matter what, security measure we come up with, people will come up with these clever ways around it, right? There's no hope of hiding it. So therefore, let's not bother having a software industry, right? In some sense, that would have been the cryptographically correct conclusion to come to, right? But it turns out that if you just make it inconvenient, a little bit inconvenient, then people will pay for software, and so I think there are a lot of social factors here that are far from obvious. But there are attacks so here's something you can do. You can ask GPT-4 write my term paper, but between each word and the next insert the word pineapple. Right, and then you just GPT-4 is smart enough to do that. Although when I tried it, then sometimes within the term paper it will actually comment on what it gosh, all these pineapples are really interfering with the legibility of this essay, aren't they? Right. So the student would have to know to take those things out. But in any case, you take out the pineapples, and then you have a document with a completely different sequence of k-grams than the document that was watermarked, right? Mm-hmm. Where all the k-grams contain pineapple. Right. So, so if you start thinking about the class of all possible attacks like those, then you start to realize that the only way that you could hope to be robust against all of it Well, okay. Well, you might just fight an endless cat and mouse game, right? Similar to what Google has done in its battle against SEO.
Sure.
Yeah.
People for 20 some years.
Big game.
You can try to detect when people are evading the watermarking. You can shut them down when they're doing it. In sometimes in a cat and mouse game, you just try to be a better cat. Right.
Does it seem like there's some proportion where it's like you want to catch the lazier people more than you want to catch like if someone who's putting in a ton of work, like they might actually be rewriting the essay.
Yeah, right.
And so it's like it's almost like something with just messing with like spaces and stuff. I think Tesla did this. Have you heard about this? Tesla. So they were having this problem where some employee was leaking internal memos to the press. And they kept seeing this email was sent internally. And so what they did is they just used the replace a few words, add a couple double spaces with the assumption that they would copy paste.
Yes.
Obviously,
if you, and that sufficed to catch the person.
Yes, and in this case it worked. And I think in general, like my intuition, correct me if this is wrong to you, is that you really want to catch those people who are doing absolutely nothing. They're like fully bull-faced cheating. Yeah. And then there's the people who are doing a bunch of work and you're like, I guess if you rewrote the essay that GPT-4 wrote in your own semantic thing,
Yeah, I mean, you could say that the limit of like putting more and more effort into cheating is to just write the paper yourself, right? Right, like that's like the ultimate form of cheating is to just do the work, right? So it's kind of like yeah, exactly. No, right. No, it's kind of like I have this theory that the Apollo landings actually were faked in a sense. The conspiracy theorists are correct. It's just that the way that they faked it, the easiest way to fake such a thing was to send people to the moon. Now I think what you would really want, to have a principled solution here would be to watermark at the semantic level, right? Now, what would that mean? This would mean that we would go inside of the neural net, right? So we would take the internal representations that occur inside of a transformer, right, where each word or each token is represented by some vector, let's say in a high dimensional space, right, and then each of these vectors is compared against every other one, right, by some other pieces of neural network, right? But now, imagine if we could jiggle these vectors around a little bit, like move them onto particular sides of this or that hyperplane, okay, in a way that we could detect later, by looking at the output. Okay, so the hard part is you want to insert a watermark at the semantic level where it might plausibly survive translation from one language to another, and translation and all the surface forms of expression.
Sure.
Right. But
is this what humans are right now doing? When you said I'm looking at the comments and I'm seeing that they are definitely LLM generated. Is that are you picking up on like the semantics of an LLM, the way that it speaks?
In some sense, I mean, like okay, to be concrete, like I got a whole series of comments saying like, well, I'm trying to be helpful, but Aaronson, really doesn't, he shows us, really appalling ignorance of the basics of quantum computing here, and he really needs to be educated on the basics of how this works. So then of course I read, I'm like, okay, what, because I do make stupid mistakes sometimes, right? But then it just degenerates into this just sort of random word salad nonsense, right? And then it ends with like a neat summary, right? And therefore, in conclusion, we say, like this is, no offense, Scott, but but like it's time to up your game and be more accurate, right? And it's like exactly the kind of thing that would be generated if you said write, if you said to an LLM attack Aaronson for his ignorance of quantum computing in the smarmiest possible tone or something like that.
Nice.
So
I
yeah,
feel like that's a good response though. Is like you're just a robot. You know,
right.
Like,
Well, like in some
what is
sense,
this?
in some sense, like the key insight was that I didn't even have to prove whether this came from an LLM or not. I'm like, okay, look, you are a troll, right? You are either using an LLM or else you might as well be.
Yeah, you low entropy dribbling.
Yeah. So I mean, of course, people can make decisions like those, right? But it would be nice if you have a tool that just flags,
sure,
like, yeah, this comes from an LLM. So I think that in the limit where you have AI on both sides of the problem, and you have AI trying to insert watermarks into the deeper semantic choices that are being made, it's not even obvious who wins.
AI on AI crime. It's the essence of the AI wars.
Yeah, right. No, I mean, we look. It's clear that we're going to a future where good guys and bad guys will both be using AI to do all kinds of things, and and like any research that anyone does, right? Well, there's an inherent problem, which like many of us just saw the Oppenheimer movie, right?
Sure,
and this is but this is not just around nuclear weapons. This is around any technology, right?
Sure.
That you can't build a technology that can only be used by good people who you like, and that can't be used by bad people.
I think that's a good segue into some research. So in researching your work,
yes.
I read a couple other papers. One was claiming that students who have smaller vocabularies, people who are learning English for the first time, coming to the U.S., they are slightly more likely to be labeled by the different watermarking algorithms because if you think about it, they have fewer ways to say something.
Yes.
Right? So it seems like maybe all Chinese or Spanish students or something like that might converge to the similar answer, even for a long form question.
Yeah.
Is there any credence to that?
I think that is a concern. So actually, it's funny that you bring that up because when I came up with this scheme, and I've been working to try to get something like this deployed, either by OpenAI, by others in this space, and.
So this has not been deployed yet?
It has not been deployed
I see.
yet. No. And as far as I know, none of the language model providers have deployed watermarking yet.
I see.
Okay. Now, there was a White House commitment on AI just a couple of months ago, where all of the major AI companies, agreed to I think 7 safety principles, and one of them was that they all agreed to develop watermarking. Right. So that sounds great. If you look at the fine print, it talks about watermarking of audiovisual content. And so there's still very much a question of did they agree to watermarking of text or not, and that might be a sticking point, but I think part of the question was just what is technically possible, right? And I hope to have walked you through what we know about that, right? That there are things that you can do even with text. They're not robust against arbitrary attacks, but they might already be helpful. And in any case, it seems like the risk is very low, right? There's the risk of false positives, for example, is extremely low. Right, and so it seems maybe worth trying, but I would say that this question of watermarking has divided people within the AI safety community. So the kinds of objections that I get actually, I had thought that it would be focused on the existence of clever ways to defeat watermarking, and that was not the main objection at all, right? The main objections were things like, who cares about students cheating on their homework? Maybe we should just let homework die. right? All right, and isn't homework cheating a trivial problem anyway compared to AI taking over the world, right?
Sure.
So I think that of course it's not the biggest problem in the world, but one wants to sort of get the systems in place to address misuse of AI, as it happens, right? And if right now that means academic cheating and and spam and troll comments and fraud, well then let's address that. Let's show that we have the systems in place to address that, and hopefully we'll learn something. Right, and we'll learn something that can be applied to the next set of safety problems caused by AI. Right, I mean, the journey of 1,000 miles begins with a step. Right, and as for the idea that homework should die or should completely change, I mean, you could argue that, but I don't think that AI companies should be unilaterally making that decision for everyone. Okay, I think that teachers should have some ability to say this is the policy that makes sense for my course. Right.
Sure.
This is what I am trying to teach here, and this is where I'm happy for students to use AI, and this is where I want students to not use AI and to acquire the understanding themselves. Right, and then it's just a question of how do you give that teacher tools to enact whatever policy makes pedagogical sense. Right, but now the other objection that I got a lot was, well, what about English as a second language speakers, right? And there many of them are already using GPT or other language models to improve the fluency of their English, and isn't it unfair to them if everything they write is going to get sort of exposed? Shouldn't they have a right to use language models and not have to disclose that they're doing it? Right, and I don't have a technical answer to that question, right?
Yeah, that's not a technical question.
It's not.
Societal
It's not.
standard.
Yeah.
It's
Yeah.
not. It's not. Right.
Yeah, yeah.
I mean, I don't know how to design a watermark tool that only works on unsympathetic cases.
I have
Yeah.
heard of employees using for example these models as ESL English second language
Yeah.
speakers to actually rewrite their emails and make them sound more professional. So
Yeah.
this is actually happening. I've heard of.
Yeah. No, I mean, I think sure, and it seems like a totally reasonable use. I mean, the only thing I would worry about is, okay, maybe people get reliant on it, and and then it saves them from having to practice and improve their English, which maybe would have helped them if they had, right? But on the other side, we might just evolve to a world where ESL speakers will be like, yeah, of course I use the language model, right? Well, why shouldn't I, right? That's what everyone does, and where they don't even feel any need to hide it.
Well, it certainly feels like the person they're communicating with should at least know where the text was generated. This is something that I thought about being useful. I think we all receive a ton of spam. People trying to tell you, send money to this bank account in some clever new way. Someone's been in an accident. It would be really nice to know, when I look at something, if there was a watermark like Shutterstock, where it's this is AGI generated text or AI generated text. Do you think that there's some way to provide that service without giving away your algorithm so that students could just use it to obfuscate the fact that they're cheating? It's sort of a different problem, but I think it feels like watermarking's.
Yeah, I mean, unless I misunderstood you, I think you're talking about the same problem of attribution or
it is
provenance.
It's the same problem, but I think the application. So if you're providing a service that people could pay for, and then it's just maybe it's a browser extension.
Okay.
And it's constantly telling you what's generated by AI or not, or some probability.
Yep.
Then if I'm a student and I just install this and pay $1 for it or whatever, then I can copy my text and then change the minimum amount of things to not cheat.
So there's certainly one of the biggest issues with deployment. Every time this discussion has come up, has been the question: who gets access to the detection tool?
Yeah.
Right.
Yeah.
And now at one extreme, you could just give access to everyone. right? You could even publish the key of the pseudo-random function if you wanted to, right? Or without publishing the key, you could just provide a web form where anyone can enter text, and then the detection, OpenAI on its server would run the detection tool and tell you what's the probability that this is watermarked. But if everyone has access, then of course the cheaters also have access, right? And they can keep modifying their document until it no longer sets the detector off, right? So now like the other extreme would be only OpenAI has access to the detection tool, right? You could say that maybe defeats the purpose a little bit, and then there were these intermediate possibilities, such as access is granted, through academic websites like Canvas or Turnitin.com, right? Or access is granted, on a case-by-case basis to journalists who are studying misinformation,
sure.
right? And so, it's possible that we're going to evolve to some kind of solution like that. But, in any case, I think that this is a broad conversation that needs to be had. I mean, I've having this conversation, within OpenAI, but also many people want to have this conversation outside of OpenAI, right? And I think
now.
Yes, right, like us right now. And I think OpenAI and other AI companies, it helps them, if they see like a clear consensus, in the broader community that some safety measure is wanted or is not wanted.
So in an effort to start that, I'm curious what your recommendation is. Is that asking too much for you to say? We're in the spectrum of
no, I'm happy to give you my recommendation, which is that I would like to see this tried. Okay. I would, like the one thing that a scientist is always confident in saying about the future is more research is needed, right? Right. And I think that's certainly the case here. Like we've never seen, watermarking of large language models actually deployed at scale, right?
Sure.
Which means we don't know what all the social ramifications are going to be. But we have approaches that can be tried, and it seems like the downside risk is actually very low. And so I would like to see these things tried, and I'm cautiously optimistic that we will actually get some of these things.
So what are the reasons why it hasn't already been implemented?
Well, I've gone through some of those reasons. I've gone through some of the objections that have come up, but maybe the most obvious objection is, well, any given AI company that watermarks its output, right, is taking a risk with its customers, right? That maybe the customers will say, well, what is this? This is a Big Brother, and this is not for me. This is for someone else to try to detect what I'm doing, and they could then switch to a competing service.
That's a really interesting problem. I'm curious. What is your what would you predict is the percentage of users that are cheating students on GPT-4? Are you willing to say that?
I don't know, and I feel like
GPT-4 is paid, so probably higher than GPT 3.5.
Oh, that's a good point.
Yeah. So I wouldn't want to speculate without having at least some data to ground that in. But I definitely a higher percentage than we would like.
Sure.
Yeah.
Okay, and but even people who are using it legitimately, right? There are some people who just don't like the idea that of a Big Brother, being able to detect what they're doing, right? And so society has to sort of decide, right? Like, do you have a right to know whether something was generated with an LLM or not?
Yeah.
Right?
It's interesting because it's not always something that would be super valuable to know, because if you just see that an email was LLM generated and you fail to read it and see if it contains good data or good ideas, you still lose. You still lose out on those ideas. So even if I used, a large language model to write Chris an email and I said, I want it to have these themes and these important things in
Yep.
it, and I send him the email, he sees it's AI generated, he throws it out. He still loses.
Yeah.
It's not actually
right.
that useful of a
I
tool.
would
Right,
remember, by the way.
Well, look. I mean, we are now in a world where tens of millions of people, ask questions to ChatGPT, and they're only asking because presumably they want the answers,
Yeah.
right? They want to read the
Yeah.
answers, and they're not throwing away those answers because they are LLM generated, right?
Yeah.
That's the whole point. Right, so as I think that people's intuitions, will have to get calibrated to what the current LLMs can do and can't do, right? And when people realize that LLMs are very reliable at a certain task, then the fact that something came from an LLM, shouldn't be so off-putting to them.
So,
right?
are there watermarks built in that emerge from just the training set of any given model that you could then detect without knowing exactly, or without having inside access to leave your own trail?
Yeah, so that was what I was calling discriminator models before,
yes.
right? So that is an approach to the provenance problem that I'm going to differentiate from the approach of watermarking.
Because an
right?
AI company would be much more incentivized to make
Yeah.
a discriminator model. 'Cause it
Yeah,
doesn't
right.
just work their
So
customers.
as I said, OpenAI tried that, right? An undergrad at Princeton tried that, right? The rate of false positives still seems to me too high to use the output of a discriminator model to alone to accuse a student of cheating, let's say,
Right,
in the absence of other evidence, right? But there's even a further problem that I didn't mention before, which is that discriminator models are trying to fight a moving target. Okay, the whole point of an LLM is to sort of predict what the average human on the internet would say, in this situation, or how they would continue this text. And as LLMs get better and better, as they're scaled up more and more and they achieve lower and lower losses, they are doing better and better at that prediction task, which means that you could expect any given discriminator model to get worse and worse. Right, which means the discriminator models have to keep running just to stay in place.
Sure.
Right?
Does this mean that in the limit, if you're like a completely mid person, you are in most danger of being a false positive, falsely accused?
Possibly, yeah. I mean, we've seen that LLMs tend to be best at generating formulaic prose, right?
Yeah.
And I've it has become a term of abuse that this person sounds like ChatGPT, right? Or this,
Yeah, people call each other NPCs now.
Yeah, right. Or this. No, but I mean, it's like you could just clearly see that the early killer apps for GPT generated prose. I mean, grant proposals, progress reports, letters of recommendation,
Sure.
all these things where it's more important to have produced a certain number of pages than what is in those pages, right?
For sure.
So of course there's also huge amounts of mundane utility, I think, that people are unlocking and that they'll continue to unlock. I think a revelation for me, when I first saw GPT a few years ago, was I thought, okay, if this is the greatest AI that the world has ever seen, right? So let me ask it, what's the solution to quantum gravity, right? Why does the universe exist, right? Does P equal NP, right? And of course it's not very impressive on any of those. It just sort of spouts about them. Okay, but what I should have been asking it is where is the missing brace in this LaTeX file, right? Or here is a transcript of a lecture on YouTube. Can you please clean it up, right? Just like the most mundane clerical work and programming work. Write me a Python program to do such and such.
Sure.
Right. It is if you haven't tried that, then it is astounding. Right, how good it can be at that kind of task, and so I think that at these sort of these sorts of mundane tasks, language models are going to have a huge impact on the world before they are writing New Yorker articles.
Sure.
Right, before we have to address the question of do we need watermarking to tell whether this literary prose actually came from an LLM, and do we care whether it came from an LLM?
So then it seems by this elimination of these mundane tasks, likely that sort of, we're approaching an era of abundance. We're going to have a lot less work to do. That'll be great. But do you think that we'll just ratchet up to adjust our living standards again like we did after the Industrial Revolution? Like everything is great now. If it gets better,
I don't know if everything is great, but I do tend to be generally in favor of enlightenment and scientific and technological progress. Interestingly, most of the AI alignment people are also very in favor of progress, but they just carve out a special exception for progress that might completely eclipse the human race. And either literally kill us all, or even if you don't believe that, just create a world where it would seem like there's very little left for us to do.
Do you, speaking of believing that, what would you say the probability of something like that happening is?
I think that depends enormously on what we mean by something like that.
Well, okay, let's just say a future where humans don't matter or even extinct within the next 100 years.
I think that there is a significant probability of humans going extinct within the next 100 years. I think that is terrifying, and we should, in a sense we already knew that, right? There were, there was, the threat of nuclear war hanging over the world for 80 years. There's the threat of, a tipping point of climate change, okay, and of running out of fresh water, and and that exacerbating war, and all kinds of things. I think that whatever if there were some catastrophe for the human race in the next century, I'm almost certain that AI will be involved. Okay. Just because AI will be involved in everything. Yeah. Right? But I think that that the causal role of AI among all the other factors might be rather complicated. Mm-hmm. Right? We could say, has AI changed the outcome of a presidential election, right? Namely the 2016 one. Well, possibly, sort of, right? But obviously it wasn't the only factor.
Yeah.
So can you put a number, or maybe on order of magnitude scale? What's your personal credence on something existential?
I mean, okay, if you put a gun to my head, I'm going to say, 10 or 20% chance of some kind of existential catastrophe in the next century.
Does that make you a doomer?
Does that make me a doomer? Right. Yeah. I don't know what these terms mean, right? Because as I said, I think that my biggest pathways to doom that I worry about are the mundane ones that mainstream people also worry about, right?
Yeah. Wisdom of the crowds.
And I just and I just say that AI will be involved because it will be involved in everything.
Yeah, that makes sense to me.
Yeah. So that's sort of like part of the Yudkowsky and game theory alignment problem. But then when you are working at OpenAI, you're sort of working in the trenches of alignment. And can you sort of link those two together for us?
Okay.
Is it a bottom-up process? Is it a top-down process? Is it both? What's going on there?
I've known Eliezer since 2006 or so, right? Since he started writing his sequences, and and realized that like many of the same people who read my blog were also reading Overcoming Bias and then Less Wrong, and we sort of interacted, and I sort of I kept it at arm's length a little bit. Right, partly because it felt a little bit culty, to me, right? And lately I've been making the joke, like, okay, when I have academic colleagues who say, well, isn't this, AI alignment thing a cult? And I say, like, well, you have to hand it to them, right? That it's, of all the cults in the history of the world, like, this is the first one whose God has actually shown up, and you can talk to But more seriously, I felt like, okay, even like supposing that I agreed that that superhuman AI is coming, which of course I can't prove that it isn't. There's no principle of physics or CS rules it out. But then what is the research program? Right, like, what do you want me to do about this?
Yeah.
Right, and the Yudkowskian program seemed to be, well, you just sort of sit and think about it, a priori a lot, and you conclude that the super AI will basically be a god that we have immanentized, right, or that we've made manifest in the world. And then you get very depressed because you say, well, there's if that God wants to destroy us all, then there's basically nothing we can do to stop it. and you write a bunch of blog posts about that, right? And and it was hard to see, well, okay, what is the research program that's actually able to make cumulative progress?
Right. Sure. We were wondering what's the base unit of alignment? Like, how do you even measure your progress?
Right. It's a good question. I would say that, having worked in quantum computing for 20-something years, right, the irony is that we still, do not have scalable, fault-tolerant quantum computers in 2023. We're a hell of a lot closer to them than we were when I joined the field, around 1999 or 2000, but we're still not there yet, right? We don't have them, whereas AI, we now do have AI systems that are changing the world, right? They actually exist now. Nevertheless, I feel like the theory of quantum computing, has been like a sort of cohesive, well-defined field since the 1990s. Where we knew, even then, we knew what many of the problems were. We could formulate them mathematically, right? They were, in many cases too hard for us to answer. But, okay, once you know what the question is, then you can chip away at it. You can make progress, right? And AI alignment, I feel like, is not, at that state yet, right? It's, maybe it's analogous to where quantum computing was in 1991 or so. When there were a few physicists sort of speculating about it, but there were not axioms that everyone really agrees on.
So I'd like to pose a hypothetical.
Yeah,
about
sure.
So let's just say that you have someone really well funded, maybe even the United States government, completely on your side for funding some sort of alignment project.
Yeah.
Maybe you have access to $100 billion and you can get top talent. How would you proceed? What are the first things you would do? Any ideas, just off the cuff?
I'm hire so a lot of smart people, right?
Yeah.
Look, I'm not sure that I would do anything radically different from what OpenAI and Anthropic and a whole bunch of other organizations interested in alignment have been doing, right? Which is to just hire a bunch of people, have them work on interesting problems in this space. Having said what I just did, there are various problems that where most people agree that progress on these problems is helpful for alignment. Okay, one of those is interpretability. Right, the more we become able to look inside of neural networks and understand what they are doing, at a mechanistic level, right?
Sure.
Be able to sort of apply lie detector tests to them, do neuroscience of neural nets, right? Understand when they are lying to us,
I think
things like that. Yeah.
That's a little bit controversial now with some AI safety people. Have you heard this?
Or? No.
So, do you know Connor Leahy?
I've heard of him.
Yeah. So. He founded Luther AI.
Okay.
It's like the open source kind of
All right.
model thing, and they've said that they're trying to not do interpretability because they feel that it advances capabilities faster than it advances safety. So there's like this idea of like, okay, yes, it's making safety better, but it's also making people make neural nets better faster than it's making safety better.
This is the okay. So this is the kind of debate people have about anything that you can propose to do, right?
Yeah.
I mean, you know, I remember decades ago reading Carl Sagan saying that he thinks that we should not develop the capability to deflect asteroids that are headed for Earth, right? You know, this seems like a clear win for safety, right? But why should we not do that? Because we are not, you know, mature enough as a species yet to have that capability, because someone will misuse it to, you know, threaten someone else that they will, you know, deflect this asteroid toward the Earth if their demands are not met, right? And so it's like you can take any kind of technical progress, right? That, like, you know, even progress that can only improve safety. Well, maybe it's just like, you know, as seat belts and airbags get better, then people respond by driving faster, right?
Sure.
They just stay at the frontier of, you know, the level of danger that they're willing to accept, right? Maybe, you know, even if you make AI safer, all you're doing is you're incentivizing someone else to just speed up AI progress.
Sure.
Right. So, you know, I think like there are all these, but I think there is a danger that you just get stuck forever in these sort of, you know, second order and third order effects, right? And then you, you know, and then you know, you are paralyzed from doing anything.
Yeah.
Right. And so that's why I try to step back, and rather than play this game of like try to predict, you know, how is civilization going to respond to AI in the next decades? You know, I don't know. My defense for not knowing is I don't think anyone knows. But even if someone knows, it's not me, right? So what I try to do instead is say, well, okay, we have, you know, the world is now different than it was even 3 years ago. Okay, because, you know, we have very powerful AIs that are now being deployed, and we can see, you know, how are they being misused right now, and what can we do to stop that? And you know, this is you know, now we're not addressing hypotheticals, like we're sort of, you know, we've made contact with something firm, right, where something in the external world that can push back against us and it can tell us whether we're on the right track or not. Right, and then hopefully we gain some knowledge. And, you know, I think the fundamental axiom of a scientist, right, is that, you know, having more knowledge seems like it should be good. Right? It's, you know, yes, knowledge can be misused, but, you know, having deep understanding of like what is the space of this problem, how do you control it in AI, you know, how would you align an AI to human values, what do we even mean by that? Right. I think that, you know, the way that people talk about these questions is already different than how they talked about them 3 or 4 years ago, before we had the example of GPT to hone our intuitions, right? And I think that, you know, the way that we talk about them, you know, will change as we see things like, you know, reinforcement learning with human feedback, you know, either succeed or fail, right, at aligning our AIs to different objectives. And so, you know, I like to say that the big irony is that so Eliezer Yudkowsky has gotten completely depressed about AI alignment, right? He thinks, you know, okay, the world didn't listen to him when it had the chance, right? Now, you know, we're basically doomed. I mean, you know, sure, we can keep working on it because maybe there's some Hail Mary pass, but basically, you know, along the current trajectory, we're doomed, right? And it's just a question of do we die with dignity, or with, and whereas I feel like, well, like you know, you can actually see a path toward making progress on AI alignment, right? Where you know that is cumulative, that builds on the past progress, where you actually gain some knowledge, and that doesn't tell me that we can bound how long it takes to solve the problem of aligning a super intelligence, but it says, okay, here are things that seem like they're along the critical path. And we can at least take some steps forward,
Sure.
right? Which even that I don't think was really true 5 years ago. So somehow Eliezer and I have like literally switched positions on how optimistic to be about AI alignment work.
So just to sum up, where would you put in terms relative to maybe the total knowledge we've accumulated about the human brain, the total knowledge that we've accumulated about like current gen AI systems? Do we understand them better or worse than we understand ourselves? And what does that tell us?
That's a very interesting question. I think it largely it depends on what kind of understanding we are talking about.
Sure.
Right? With LLMs, we have something that we have never had with biological brains. We have the ability to look at every single synapse, every single activation, at every point in time, look at counterfactuals, suppose they did this, right? And each thing is just a matter of changing a few lines of code. It doesn't take like years of wet lab work to go in and change something, right? So that is just a ridiculous amount of transparency that we have that we've never had with any biological organism, right? But of course, with our brains, we have something that we don't have with LLMs, which is introspective access.
Sure.
Right, and that has to count for something, right? So I think that for some questions, I would say that our understanding of LLMs is already much more detailed than it is of the brain. But for other questions, I'm sure I would say the opposite.
Mm-hmm.
Do you think there's any way to connect your work on complexity theory to AGI, to work on AGI, or
I've been
help each other?
Yeah, I've been trying to figure that out. I mean, that when OpenAI came to me in spring of last year, saying like, "Do you want to come, go on leave and come work with us?" I mean, that was their pitch, basically, right? That like we think that complexity theory is actually relevant because I was like, why do you want me? Right? I'm a quantum computing person. What do I know about AI? But they felt like, first of all, like the sort of a physics perspective was helpful, and second of all, that a complexity perspective. So like in one thing we know in complexity theory a lot about is how to verify the claims made by a super powerful but untrustworthy prover, right? Like there's a famous theorem called IP equals P space, right? Which basically says that like if some angel came to Earth, that played perfect chess, right, then it could prove to us, for example, that white has the win in chess, or whatever is the truth about chess, and we would only, and it could do that via a short interaction. Okay, and we would end up being statistically certain of the conclusion, even if we didn't trust the angel.
I see.
Okay?
So it wouldn't reveal how, but it.
Right, exactly. So it wouldn't mean that we could now play perfect chess, but we would be, statistically certain that the angel, not merely that it was better than us at chess, which of course it would be, okay, but that no matter how we played, it would have won. Okay, that's the counterintuitive part, right? How do you prove a statement like that by a short conversation? It turns out that you have to translate chess into a different game involving sums of polynomials over finite fields. Probably a less fun game, but it's a game that we that's sort of equivalent to the original game. Like whoever wins that one would have won in chess. Mm-hmm. But this game has these error correcting properties that are that come from low degree polynomials that chess didn't have. And so the idea that the OpenAI folks came to me with was couldn't something analogous to that be done for AI, right? Because also in AI you have this super powerful but untrustworthy entity, right? Now it's not like a a hypothetical angel, or a prover, or Merlin, as we call it in complexity theory. Now it's this actually existing AI system, right? And then we have these these weak verifiers. In this case, that's the humans, right? And so can we have some kind of guarantee that if the AI is lying to us, then we will catch the lie, or something like that. So I still find this an amazing source of analogies.
Do you think that's true?
Yeah.
Do you think we could catch an AI lying to us?
Well, maybe.
The problem is in p-space or IP.
Right. Part of the problem is that the questions that we really care about with AI tend not to be mathematically well-defined ones, right? Like, what do we mean by the AI lying, right? Or what do we mean by the AI loving humanity or hating humanity,
Sure,
right?
sure.
Translate that for me into a question about polynomials over finite fields, and then maybe we can get started.
It seems like the difference. The difference that I observe between like the chess scenario and like the real world is kind of this like dimensionality problem where there's like the move space for the next move in a particular game. Like chess has a certain number of moves that's more than checkers, but less than Go.
Yep.
And life, like when we're out here outputting, the next word token, the move space is huge. And if you're outputting images as well, or you're outputting different controls to a mouse to control a computer to do something or design a technology, that's many moves, right?
Yeah. That's interesting, because I don't think that the issue is the move space at all.
It's not.
No, not at all.
What's the issue?
So in both chess and in life, we have an exponential space of possible moves, right? And it's true that in chess is commonly played on an 8x8 board, and then maybe there's a merely 10 to the 43 or something like that board positions. But these famous theorems like IP equals P space, they would work equally well if we were talking about chess on a 1,000 by 1,000 board, right?
Okay,
we could make the board as enormous as you like, make the move space as enormous as you like. These theorems still apply, right? Mm-hmm. So what is the key difference between chess and life? It's that with chess we can mathematically define what it means to win or lose. That's the difference. Right? Okay. Chess is a well-defined game, right? Life, or as a special case of life, AI alignment. What does it mean for the AI to produce a good outcome for humanity? Right. What does it mean to win in this game? Right. So, that is not if we knew how to mathematically define that, then we'd be like 98% of the way to solving the problem.
That's this is really interesting. So I feel like, do you think there's any possibility to have multiple angels and have them be adversarial so that they have incentive to check one another's solution?
That is in fact one of the main ideas that people have had. So actually, Paul Christiano was a former student of mine when he was an undergrad at MIT. Did quantum computing for a while, and then switched to AI alignment. Right, did this crazy thing. Like what quantum computing person does that? Well, he did that in 2016, which was I guess like 6 years before I did it. Right, but and he's become a leader in this area. And one of the things he pioneered, while he was at OpenAI, was the reinforcement learning from human feedback. That is the main way that they sort of get a GPT to produce friendly, inoffensive outputs. But another thing that Paul has thought about a lot is exactly what you suggested. Can we get multiple AIs to debate each other, right? And then even if let's take an analogy, right? Like because of my interest in quantum information, right? In the last decade, I've often talked to the high energy physicists like the quantum gravity people, the string theorists, because they have come increasingly to feel like quantum information is at the center of what they care about, because of these dualities, because of the black hole information problem. But this has been a big problem for me because I don't know what the hell they're talking about, right? They're talking about supersymmetry and type 2B, heterotic strings. I can nod along and pretend that I understand.
That's what I'm doing right now.
Yeah, right. see, there you go. It's like we're all lay people except in the few specific things that we know, right? Okay, but what I found repeatedly was that if I could just get two string theorists who disagree with each other and just get them arguing, then I can sort of see who sounds more plausible, right? And I have much more ability to do that than I do to judge the credibility of a single one in isolation.
This to me
Yeah.
seems like empirical evidence that this works. You've already done it.
Yeah. Now, of course, what the orthodox alignment people, like the Yudkowskians, what they would say is that, well, we should imagine an AI that is just so far beyond us that, if you have multiple ones, you might think that they're debating each other and actually they're colluding to, just convince you of a falsehood. Of course this is all possible, but, even if this gives us, one additional lever, I think absolutely we should be thinking about things like that. We should be thinking about sort of what's become known as iterative amplification, right? It's like, suppose that we come to pretty much understand and trust GPT-4, right? Like, we feel like, okay, it has a certain profile of capabilities. It's it's not secretly plotting to destroy us or whatever. Well, then it would stand to reason that we should use GPT-4 as a central tool in testing GPT-5, right? And then once we trust GPT-5, we should use that as a tool in testing or aligning GPT-6 and so forth. Right, but how do we think about that? Because it seems like as long as like a human is the ultimate arbiter, like like you could imagine having a corporation where like the human is the CEO, right? And now you have some GPT-4 vice presidents who are supervising, some GPT-5 managers who are supervising some GPT-6 employees,
Sure.
right? But the buck stops at you, right? Well, then that it seems like, okay, maybe there's some limit of that process, right, that we could get to. But then, what alignment people talk about is like, could you go even beyond that limit, right? Like, what would it even mean to align an AI where it's solving problems that are so hard that the answers could not be made comprehensible to you even by such an iterative process, right? Like, I'm not sure if that's even meaningful. I think maybe the limit of what can ultimately be made digestible to us is it contains the limit of our moral universe, contains the limit of anything that we could possibly care about.
Yeah, so we wouldn't care about these problems that they solved. I've solved n-dimensional space probably with something like, okay, that's great AI, thank you. Now make more paper clips for my factory.
Right. No, I mean it's a very interesting question, right? Like, are there? Well, let me put it this way, right? It's clear that there are abstruse truths, in math, in physics, right? There are true statements that can take a decade of study before you even understand them, right? Is there such a thing as abstruse truths in morality? I'm sort of skeptical that there are.
Me too.
So that might be a good place to leave it.
All right.
Is it? Yeah. Is there anything that you'd like to say or plug before we go?
I'm not hard to find on the web. Anyone who wants can go to scottaaronson.com and they can see my blog, my book, my lecture notes.
It's a great blog. We all
thanks.
read it, so,
Yes.
Thanks.
yeah, we
Thanks.
really
Thanks.
appreciate it.
Thanks.
Yeah.
Thanks
What
a
would you
lot.
advise a young, maybe undergrad student? Should they go into complexity theory or AI safety or?
Well, it's very hard to answer that question without meeting the undergrad first, and finding out a little bit about them. Right? I'm always getting requests for advice, and you have to. It's much easier if you can find out what the person is passionate about. But one thing that I'll say is that almost everything that I've cared about in my career has been somehow downstream from math, right? Like if you get better at linear algebra, get better at doing probability theory, like that is not going to serve you ill in like any of the topics that we've talked about.
Maybe that's a really good endpoint because we could just say, don't cheat on your math homework.
Yeah.
Actually do it.
You're only cheating yourself.
All right. Well,
All right.
Thank you so much.
Yeah, sure, no problem.
You are listening to the AI Wars podcast.